Okay, great. For those of you who've just joined in, please do mark your attendance. And this week we'll continue to discuss the what is this? The first, second, third component out of seven that make up the built environment that we live in. So, and wait. Yeah. Products. That's right. Yes. We've discussed products, we've discussed interiors, and now we will be discussing structures, buildings, architecture, and then before we will move on to next week's discussion of landscape, cities, and so on. And hopefully by the end of, or hopefully by the second half of this semester, we'll be able to tie those components in and understand and better understand how each and every one of those components react. So as I mentioned earlier, structures represent the third component of the 7 layers of the built environment to be examined in this unit. The building of structures establishes human/social, environmental, and technical relationships and constitutes a basic creative act, one that has occurred throughout human history. Building is a primary adaptive design strategy for us humans, and for that matter, perhaps even for many other animals and insects. So we're not the only ones engaging in building as an activity or building shelters as an activity, but some animals. But mammals or insects also engage in the same activities. You see birds building nests. You see rabbits and other rodents dig holes to build a network of layers and tunnels. So it's all part of an adaptive strategy that we have all developed in order to live a more comfortable life and to live more comfortably, to live more effectively within the natural and built environments. The act of building symbolically expresses shelter, permanence, and reflects cultural values. Structures both inside and out can be defined as structures, the contents of which are products and interiors, and structures are humanly made or humanly arranged, of course, fulfill human purposes, satisfy human needs and wants and values, and mediating the external environment. And like any other things, like the products that we've discussed, like the interiors that we discussed, the results of building as an activity affects the overall environmental context. And the context for structures include landscapes, cities, regions, and ultimately the land upon which they are built. It is difficult, if not almost impossible, to have a general approach or a generalized approach or generalized thought about structures. Structures exist in many different types, many different sizes. There are structures, old and new, crude and refined, express many reasons for us to build. Only human insights, interests, and imagination limit the types of structures possible. Although not not just imagination. I mentioned last week how technological advances have made certain design approaches or certain construction approaches or certain construction techniques possible. So imagination, technical capacity, and technological availability limit the types of structure possible. Simply observing the built environment should enable anyone to list a variety of structures that serve individual and collective needs, wants, and values. As the most basic structure, shelters have been created in an enormous variety of shapes and sizes. Community structures accommodate cultural, commercial, and governmental, educational, and recreational interests. Even bridges, circulation systems, dams, power plants, and engine networks and structures created to interconnect society in various ways. The cumulative effect of building on or with the land creates larger components of the built environment. For example, a farmstead, a campus, a neighborhood, village, or city, even large metropolitan and rural regions are influenced by the way we collectively build and arrange our structures. Structures, especially buildings, have a unique and perhaps even a dual role in the built environment. They have both an inside and an outside. Structures help to mediate between people and between both the natural environment and the surrounding built environment, creating a unique and dynamic relationship within the total built environment. This dual role of designing both an interior and exterior is not shared by other design fields. Exploring interior and exterior properties can expand the appreciation and the understanding of structures and the human environmental interrelationships with the natural and built environments. Now, internally, structures satisfy and symbolize human spatial needs, wants, and values. They creatively configure products and interior spaces in a variety of ways to support human needs and aspirations. Spaces for human activities are essential ingredients of a structure. Now, this internal property is commonly referred to as the spatial or functional aspects of structures. The picture that you see here is a picture of Notre Dame du Haupt. Pardon my French. My French is completely rubbish, but this particular church was designed from the outside in. So the initial shape or the overall shape of the building was meant to represent a pair of hands that are clasped together in prayer. And then the inside or the internal structure sort of the internal structure sort of gives you a different sensation than, say, a Gothic cathedral where the windows are high up. Here, the designer, the architect wanted a playful interplay of light. So they experimented, or they chose to introduce different inlet sizes, not inlet shapes. They're all squarish, but different inlet sizes and different inlet depths. Giving different degrees of lighting. So, but if you talk about human values, or I think the idea of the church taking inspiration from a clasped pair of hands, whether it's like this or whether it's like this. It's still open. It's still open to interpretation. Other people Other people interpret the building's overall design as akin to the kind of hats that religious clerics or government officials used to wear in medieval France a long, long time ago. So that was internally, and now externally, structures also provide and symbolize a protective envelope, an interrelationship with the outside environment. Now, this external expression is commonly referred to as the form of structures. The form becomes, in a sense, an enclosure that mediates the conflict between internal functional needs and the external environment. Now, this enclosure forms the interior environment, which protects humans from the unwanted aspects of the exterior environment, such as uncomfortable temperatures, strong winds, or disruptive noises. The enclosure can also open up to beneficial aspects of the outside environment, such as a garden or a beautiful landscape, natural lighting or daylight, fresh air and ventilation, even pleasant fragrances and the sounds of water, birds, and perhaps even music from your neighbors. The external enclosure can be considered closely analogous to the skin of the human body, skin, quote unquote, which also becomes the sun's warmth. Say, like, it's like our clothing. Our clothing provides insulation from the winter cold or from direct exposure of the summer sun. Our clothes, the clothes that we wear, have pores, and its pores open to provide evaporative cooling. Same with buildings. We have windows. We have windows and other means of ventilation that act as pores that open to provide evaporative cooling in very hot temperatures, and we can close those pores during the colder weathers to prevent heat from escaping from the inside. Now, the house that you see here is a house designed by architect Frank Lloyd Wright. It's called Falling Water in Bear Run, the United States. Personally, this is my favorite. This is my favorite piece of architecture, mainly because I absolutely love this piece of architecture. I absolutely love this house. Mainly because of its cantilevered design, cantilevered structures that make it look as if it's floating off the ground. It is geometrically speaking, it's a very, very massive. It has a very massive. It has a very massive and very heavy presence to it, but because of the cantilevered designs. It makes it look as if it is floating above the landscape rather than the house sitting on top of the landscape. It makes it look as if the house is a temporary addition to the natural landscape around it. But yeah, that is open to debate. But that's my take on it as a former architect myself. Now, human comfort, which is usually influenced by light, fresh air, and optimum temperatures, is based on human senses and is provided either by natural means such as windows for light and ventilation, solar energy for heat, shades for cooling, etc., or by artificial means, electric lights, mechanized heating and air conditioning, etc. Designing structures without a full understanding of the advantages and the disadvantages of natural and built technologies generally cause higher operating costs and high rates of energy consumption. from a from personal experience, my previous house was was not designed in a way to optimize airflow and natural lighting, and that has huge implications on the overall operational cost of the house. And the current house that I reside in, we've designed it in a way to maximize ventilation, maximize natural lighting, and that has cut our operational costs, or the operational costs of this house, down to 2/3 of the previous house. So, whoopee. Um, the external expression, the characteristics of form, also has a direct effect, even at times of a major impact on the overall built environment. Structures can be created to enhance or disrupt the landscapes, cities, and regions in which they're built. How structures fit into their context or adjacent environment is an important topic in studying the external form of structures. This is these are a few shots of the works of Danish architect and Danish architectural firm BIG, or Bjarke Ingels Group, and they designed the Danish pavilion in the Shanghai World Expo in 2010, among others. And so this scene, or the picture of this multi-story and multi-unit or multi-dwelling unit structure is an example of how Bjarke Ingels tried to fit the structure that he is introducing to the local environment. And you can kind of guess that, okay, so the actual environment or the actual landscape that this massive complex will be built in must be situated in a mountainous area. And what he's trying to do is he's trying to he's trying to merge the built structures into the landscape, making it look as if, or seem as if, the new structure that he's introduced, has always been part of the landscape. Whether he succeeded in pulling that off or not, I don't know. There are a couple of other examples. If you are interested in looking at such concepts where the architecture tries to meld into the landscape, then you can Google the Chongqing Magic Mountains. I'll just put it in the chat here. Magic Mountains in Chongqing, PRC. If you're interested in looking into that. So, structure, building, architecture. It is throughout this lecture, I may use these three terms intermittently. However, there are key quantitative and qualitative differences in the apparent definitions of these three related terms: structure, building, and architecture. Structure is something constructed, such as a building, dam, or bridge, and to arrange or compose or interrelate, connect all parts to a whole. That's structure. A building is a structure that is built but a building also generally implies that there's human occupancy. Um, Building is also, as a verb, is an activity to construct the work of assembling materials into a structure. That's the building as a verb, building as an activity. And then architecture, the art and science of designing and building quality open areas, quality structures, quality communities, and other artificial constructions or environments with attention to their aesthetic effect. Um, as a trained architect, I often hear from my teachers and from my peers, um, making architecture making architecture is constructing a building and taking it 2-3 steps further. So there is a general there is until now a general recognition whenever my friends who still practices architecture show off their work, we would say, oh, this is just a structure, oh, this is just a building, this is not architecture. Every now and then, if they pull something really, really good, then we say, okay, this is more than a structure, this is beyond the building, now this is architecture. Now, this simplified timeline of architectural development and evolution, if you can see it clearly, I think the words may be a bit too small, but this simplified timeline demonstrates how ideas and trends overlap, and sometimes ideas and trends run concurrently. Many approaches are recycled and they mature in later periods. In other cases, designers would combine or fuse together multiple ideas in a more effective way to address human/social, environmental, and technological issues. So the study of past trends may allow us to predict trends in the future and understand the maturation or how various approaches to architecture and construction mature. Now, my teachers from our neighboring department, the Department of Architecture, will be very, very disappointed in me if I don't feature local architecture in this lecture. But what better way to display our proud history of architectural tradition than to highlight their cultural significance? Now, a substantial portion of the built environment includes structures, landscapes, infrastructure, and cities constructed by previous generations. Now, these inherited artifacts provide a tangible record of the aspirations, of the technologies and cultural values of human civilization. We have, as a nation, a very, very rich architectural tradition, which oftentimes go unnoticed. However, our architectural tradition reflects different cultural values from one island to another. So, how many cultural groups do we have? Many. That is as many architectural styles and building styles that we have in our nation. And we do have, and sadly, these sort of inherited artifacts are getting more and more rare, as I should say. So we do have a responsibility in preserving these old traditional structures, these old traditional architecture. I shouldn't say traditional structures, sorry. But other than that, we also have the responsibility as planners and as designers to perhaps interpret these values and bring them into the 21st century and perhaps pass it on and perhaps even pass it on to the future generations. Current and future generations, like us and whoever comes next, we must make choices. We must make choices concerning how to treat these historic buildings and historic neighborhoods. A small percentage of structures, or a small percentage of structures, buildings, and architecture revered for their association with famous persons or architectural achievements should be protected from alterations. However, a vast majority of historic buildings are capable of being reshaped and adapted to suit the needs and aspirations of contemporary culture. Some buildings and neighborhoods will be recycled for new uses, while others will be replaced by new development. In the case of these traditional architecture, perhaps for us to continue to build according to the tradition, using the same materials may no longer be sustainable. Perhaps we can replace these materials with something new. And what we're translating into today and into the future for our children and our children's children would be the values that these traditional architecture or architectural masterpieces, I would say, the values that they embody. These values can be translated into the future, such as this. So again, new development doesn't mean that our traditional architecture should be forgotten. We can retain the shape, we can retain the ornaments, replace the materials, retain the values. All we're recreating these values. We are recreating these values in using new materials, using new technologies, and then we are giving new meaning to our traditional architecture and to our proud tradition. And that brings me onto our next, into the next section of our discussion. Now, historic places and historic places, historic buildings, historic architecture create cultural layers in the built environment that offer temporal dimensions and enrich the texture of our cities, the texture of our towns, our campuses, our neighborhoods, and our buildings. And I'd like to tie this little section in of this week's topic with the designer's responsibility portion of my lecture a couple of weeks back. Which designer responsibility? This one. Give me 2 seconds. The designer responsibility, or the planner's responsibility, whichever way you would like to call it, consists of five questions. 5 questions that we should ask ourselves before we begin to manipulate the built environment, before we even begin to put thought onto paper, or before we even accept or decide to accept any kind of work that is commissioned to us. Are there environmental impacts? How does it affect resources? Does it produce waste? And is it safe? And how are the impacts on human health and so on? So, historic preservation is an umbrella term that is used to describe the advocacy, research, planning, design, and construction activities associated with protecting historic structures and contexts. Most planners, architects, and interior designers will work with historic structures and contexts during their professional career. and their specialized knowledge is required to make appropriate design and planning decisions concerning historic structures. There are three common strategies used um, in a in a historic preservation effort: preservation itself, restoration, and then the third strategy is rehabilitation and adaptive use. Or should I say rehabilitation and adaptive reuse? Preservation is a design strategy that involves taking actions to sustain the existing form, sustain the existing integrity and the materials of an historic property. Let's say the statues and the heads of and the statues and the heads that you find in on Easter Island, or the pyramids of Giza, for example. In a sense, preservation can be considered an ongoing maintenance program. Change happens gradually and incrementally. Historic materials, which may be quite worn, are maintained rather than replaced, so that the wear and aging process are visible and continue to convey a sense of time. For example, the original unpainted siding on a barn or old glass in a storefront window. I mentioned the pyramids of Giza and the pyramid complex, and the pyramids found, pyramids and other ancient structures found in Egypt and Rome, for example. You don't replace the materials. What they do is they reinforce the structures. Um, Sometimes even treat the old materials, treat the damaged materials to ensure their structural integrity, but they don't replace the materials all at all. If they do have to replace it, then they will try to recreate it as accurately as possible. But that's not exactly preservation. That's more to restoration, which we'll talk about in a bit. Examples of places where preservation strategies are used to maintain structures or their intended purposes include barns, private homes, university classroom buildings, and theaters. During the life of most historic structures, modifications are made to accommodate changes in functional needs or stylistic trends. Now, these changes may assume historic significance in their own right. These changes are generally found in the changes of the changes in preservation that I just mentioned is generally found in um, in older buildings where occupation and activities continue to take place. For example, the medical faculty, in Surabaya, in Erlangga University, they occupy a very old structure, a very old building, but with the advancement of medical technology, they have to renovate, while at the same time preserving the overall structure of the campus. And I'd say that it's not an easy task to do. But my hats off to them, to the historic team, and to the engineers that can both preserve and adapt the building to new to the advances of medical technology and medical knowledge. The process of restoration is used to bring a building back to a specific and significant point in time. Usually, bringing it back to its original state by accurately depicting the form, features, and characters of a property as it appeared at a particular period of time by means of removal of features from other periods and reconstruction of missing features from the restoration period. Restoration processes involve removing materials and layers of changes that may have been added in order to clarify the original design intent or architectural style or association with a significant historic event or significant historic or famous person. In some cases, materials and changes that may have become significant in their own right are removed to more accurately reflect an earlier period. As a result, restoration processes can be the most invasive of these primary historic preservation strategies. The picture that I'm showing you is an illustration of a tragedy that struck one of the world's most iconic architectural heritages, the Notre Dame Cathedral. A fire destroyed the cathedral. Even the spire that stood behind these walls eventually collapsed. Now, I would imagine the immense effort needed to restore the cathedral as historians, architects, engineers, and craftsmen scrambled to accurately recreate this iconic cathedral. I was pretty saddened by the tragedy that struck this cathedral, because as someone who is trained in architecture and as someone who used to practice architecture and as someone who studied the Notre Dame Cathedral, although not extensively, but studied the cathedral at some period in my life. I was pretty saddened, pretty disappointed that this actually happened, and I followed up on the restoration processes. I think at some point after they had tackled the fire, after they've cleared the debris, the historians, architects, engineers, and craftsmen were thinking, if we were to restore the cathedral to its period correct state, then we would need to find the same wood they used to construct the roof, and some of these wood wood that come from certain tree species, they don't exist anymore, or at least they have to be a certain age to be able to give it the same nuance or the same atmosphere. I think some of the wood that were burnt down some of the wood structure that burnt down came from, I don't know, 800-year-old trees or so. And I haven't even touched on the roof cover, or maybe even the floor tiles or other ornaments that may have gone up in smoke as well. It's an immense effort. Good luck to them. The third strategy is rehabilitation and adaptive use or adaptive reuse, and this strategy is the most commonly used historic preservation strategy. Rehabilitation is defined as the act or process of making possible a compatible use for a property through repair, alteration, and addition, while preserving those portions or features which convey its historical, cultural, or architectural value. Rehabilitation usually involves preserving the original designs and materials of an historic structure while making alterations necessary to accommodate changes in function and use. When buildings no longer when buildings can no longer accommodate their original uses, they're often recycled for other purposes. The pictures you see here are of Granville Island in Vancouver, British Columbia, Canada. It used to be an industrial estate. To be precise, it used to be a cannery where fishing boats come in, unload, and get their daily catch preserved and canned. I think there were also other functions, but it came to a point where the activities in Granville Island were becoming too disruptive and too destructive, and so they shut it down. Because as the city grew, this island, which used to be in the urban periphery, they get sucked in to the center of the city, and nobody wants an industrial estate in the center of the city. And so they abandoned the buildings, and the city government decided to rehabilitate some of the structures, and they adapted it to new functions. Now Granville Island is home to one of the largest public markets in British Columbia, where they sell fresh produce instead of being a factory or being a cannery plant. Another example, I should have put the pictures on these slides. Another example is if you care to Google, or if you care to search, another example of a similar rehabilitation happened in Darling Harbour, Sydney, where a similar situation like Granville Island. Darling Harbour used to be an industrial estate. There used to be factories, and it became very, very disruptive, because as the city grew, as Sydney grew, Darling Harbour, which used to be in the periphery, they become part of the city center. And again, nobody wanted an industrial estate or an industrial establishment in the middle of the city, especially a polluting one. And of course, there were also economic changes at some point, and jobs were lost. Darling Harbour was abandoned, and now it has been rehabilitated. It has been rehabilitated about 100 years ago, and they continuously readapt the place, and now use it. And for the past 100 years or so, people have been coming to Darling Harbour as for recreation purposes. But they have an exhibition hall. There's a Darling Harbour Aquarium. There are of course private docks and jetties there, and other functions that I can mention from my last visit there was of course playgrounds, and I think there are a few museums there, and what was the other one? Several media companies also established their headquarters there. So it's a bustling and a very vibrant, multifunctional district now. The benefits of historic preservation are multifaceted. Historic preservation processes help to preserve cultural continuity. It protects neighborhoods. It conserves energy. It's a reinterpretation of history, and it does enable people to experience the vitality and the complexity of a multi-layered built environment. Now, every structure features materials that contain embodied energy or energy that has already been expended and can continue to be harnessed. The sources of embodied energy include energy used to manufacture original materials and transport them to job sites, as well as labor and energy used during construction. Embodied energy is usually lost through demolition. Instead, additional energy must be used for new construction to extract, manufacture, and transport new materials to job sites, to build structures, and to dispose of old materials in landfills. Preservation by capturing this embodied energy on site can be considered the ultimate recycling program. Because mechanical support systems do not exist yet, historic buildings were frequently designed to use passive technologies that optimize access to daylight and conserve energy. Some old school buildings generally had rectangular footprints with their long axis running east and west. That affords generous access to high angle or indirect daylight and ventilation through operable windows on the north and south facing sides of the building. The advent of mechanical systems and electricity enabled designers to substitute natural or renewable energy sources for daylight and ventilation with energy-intensive artificial life support systems to regulate comfort for occupants, such as air conditioning. Their intentions often backfired. The impact of artificial substitutes on health, productivity, and energy consumption are being recognized in the design of contemporary workplaces now. Historic buildings can also provide a paradigm for more effective design responses to climate. Historic components of the built environment also embody the hopes and aspirations of previous generations. I'm going to try and slow down a bit because my connection seems to be unstable. Historic components are or can be said as living artifacts that afford opportunities for first-hand tangible contact with history. For example, well, it may not look like it now, but if you take a look at the staircase, the main staircase or the staircases in our department, or hang on, I think you guys have been doing online education since the beginning of your education career in ITS. So you may not have seen these staircases, but just imagine a set of staircases in our department's building. As you ascend, as you go up these steps of the campus building of our department, you may feel, and this is a big, bold and italic may, feel a connection to the students who climbed those same steps several years before. And perhaps 100 years in the future students will also feel the same connection to you, in a way, indirectly, through those steps, if you get what I'm saying. They may feel a connection to the students who climb those same steps, and perhaps to even the same traditions that help to forge this institutional identity. Historic contexts provide cultural layers and experiential complexity that cannot be replicated in new developments. Historic buildings convey a sense of permanence and they contribute to the unique cultural heritage and the identity of a community. They provide a tangible connection to a community's history. So we are a community of learners, and our schools, our campuses, our buildings are a tangible evidence of our community's identity, our community's history, and they embody our community's values. So, up to this point, does anybody have any comments or questions?
Sir, I have confused with the term of passive technologies.
Passive technologies. Okay, thank you very much for that. Allow me to clarify. Um, there are two types of technologies in buildings that help us to moderate the external environment. Let's take temperature, for example. We erect buildings to provide us with spaces of comfort, and one way to accommodate the need for comfort is to moderate or modify the external temperature. If it's too hot outside, then it should be cooler inside. If it's cold outside, then it should be warm inside. Now, with passive technologies, the way you modify these temperatures is through thicker walls or operable windows that you can open and shut, so that if it's too cold outside, all you have to do is close the windows, close the doors, and you should be nice and warm inside. Conversely, if it's too hot outside, open the windows, open the ventilations, open the doors, and let the air flow through to make the inner space or the interior cooler. And the way and if you only use wall thickness, if you only use windows that allow cross ventilation, that is called passive technology. Active technology, on the other hand, rely on mechanical means to modify the climate. You use air conditioning, or perhaps use a fan. The use of a fan, air conditioning, heaters, gas heaters or electric heaters, those are mechanical or active means of modifying the external climate, or moderating the external climate to make the internal climate more comfortable. With passive technologies, you don't use energy that much, if at all. You simply rely on the way the internal spaces are arranged, and also relying on how big a window can you fit in the walls to allow as much natural light in as possible. But with active technology, then with a flick of a switch, you have the air conditioning on. With a flick of a switch, you have the lights on. But at what expense? To generate electricity, generally you would have to burn fossil fuel. Although it's not you who burn the fossil fuel directly, but somewhere else, the national electric company is burning coal to generate electricity. and that's not sustainable. And so whenever you turn on your air conditioning, one, you're consuming resources. Sorry, not just you. We are consuming resources, and two, we are also releasing dangerous chemicals in the air and in the atmosphere. So, in short, passive technologies mean passive ways of moderating the climate or moderating the external environment. On the other hand, active technologies means using mechanical means. If you have ever heard of anyone working on a building project or a construction project, and then you might have heard of the term mechanical and electrical engineering, sorry, or MEE, mechanical electrical engineering, and that's usually the person in charge of the mechanical and electrical engineering of a building is usually in charge of the HVAC or HVAC, heating, ventilating, and cooling system of a building. Passive technologies can only go as far. I don't think that it is ideal to use passive technologies if you were to erect a 100-story building, for example. Can you imagine the wind speed in the 100th floor or 150th floor? That must be very, very devastating. That must be very, very uncomfortable. So, up to a certain point, passive technologies can only go up to a certain point. If you decide to build higher, if you decide to build bigger, then you will at some point need some degrees of mechanical engineering or some degrees of active technology. I hope my extended explanation have cleared things up for you.
Yes, sir, that's very clear. Thank you.
You're welcome. Does anybody else have any questions or comments? Maybe an additional note on rehabilitation and adaptive use. As planners and designers and builders, or as people studying the built environment, and as people who live in cities, I assume that we all live in cities. We may have seen a few buildings that are underutilized or that have been abandoned, unused. I guess rehabilitating and adaptively reusing these buildings would provide would really make sense, and it would help the city. It would help the city rid of eyesores or urban eyesores. And it avoids brownfields in the middle of the city. I would say, if we can adaptively reuse and rehabilitate and reuse abandoned buildings. In Surabaya itself, I would say I would use the example of the high-tech mall. High-tech mall that is situated along Kusuma Bangsa Road. It used to be a very vibrant place where people would come to shop for electronic components, namely computer components. And other than computer components, they also used to have, there used to be a department store, there used to be a supermarket, there used to be restaurants and many other and many other functions there. It used to be a hustling and bustling place. But I think at some point, people start to abandon the place. Less and less visitors come there, and now I think there are less than, I don't know, correct me if I'm wrong. I think there are less than 100 vendors there, maybe even less than 50 vendors there. Most of the vendors, most of the tenants there have moved their shops from a physical store to online platforms, and the place, it's a pretty big building. The place is now becoming more and more rundown. I think if you, I don't know, if you feel like exploring the place, it almost feels like exploring a ghost town now. And structures like this, places like this, if we can rehabilitate and we can adapt it for new uses, I think would present a very good opportunity um, to recycle and breathe new life to otherwise underrated buildings. Um, because as far as I'm concerned, if I look at it, if I see an abandoned building, all I see is renovation potential. There's a possibility of using this for that, using that building for this, using that for that should be a cafe there, that should be a library there, that should be this and that, this and that. It's just, it's all sorts of things, and it is one way, that we can minimize the horizontal growth of cities by focusing ourselves inward, by reorienting our development visions inward, and try to find out as much of these unused structures as possible, and using them in clever ways. I think so. That's my additional notes. A few additional notes on rehabilitation and adaptive use. If you care to comment on that, please do. You're more than welcome to do so. Okay. Well, otherwise, if please do mark your attendance if you haven't done so. Thank you all very much for joining me on this beautiful morning. And I look forward to seeing you all again next week. Oh, hang on, excuse me, sir. I need to change my. Yeah. So, okay. For those of you who have post lecture questions, or maybe questions that arise after the class, yes, you can send me an email, or you can post in the forum section of our classroom. Whichever way is more convenient for you. I'll provide you with my email address here. Wait, which one is it that I should be using? You can contact me on this email address that you can find in the chat box. So if you have any questions, maybe not immediately after the class, but if you have questions, say a couple of days after the class, after you've read some other things, then please feel free to shoot me an email there, and we can get the discussion going. We can get the discussion going online, and even perhaps bring it into the next class, the next session. So you're more than welcome. Thank you very much for, again, thank you very much for attending, and I will see you all